how about quotient rule in order to differentiate? So when you have a quotient, how to do that? This is a little bit more tricky, and I think the best way how to do it is just to learn this formula by heart. I will show you in a second, and then you can apply it very quickly. And maybe I just show it to you. I will also calculate, of course, an example in a second. So let's have a look at my piece of paper. Can you see? So it's a function fx u divided by v. So both functions, as well in the numerator as in the denominator, both depend on x. And then the solution is this. So the way how you do it is you subtract. First we have two products. First you differentiate u, let v be the same, so the first product. Then you subtract, let u be the same, and differentiate v. So it's very fair since both functions become differentiated once, right? So that's how I memorize it. And in the denominator, you just leave the v, but you have to put in the power to the power of 2. So v of x to the power of 2. This is how I memorize it, but of course you may have different ways how to memorize it, or maybe you can even prove the rule with some other rule, differentiation rule. But I think the easiest way how to apply the quotient rule is just to learn it by heart, and then you can solve this type of exercise very, very quickly. So this is basically how it works, but I will also show this formula in a second in the clip, and also show you an example. And of course, practice makes perfect. How to do differentiation with the quotient rule. This is a little bit more tricky than, for example, the power rule, but it's also doable, I think. What you just need is practice, 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 and then you will have success with the quotient rule. So the way it works is we have a quotient, and in the numerator we have a function which has some x, and also the denominator we have also a function, but which is different, which has some x in it. So we want to differentiate this, and the way we can do it is actually we could take it apart, and then in the end we would also come to the same result as the quotient rule. But if we learn the quotient rule by heart, and if we can simply apply it, then it might save us a lot of time, and also might save us some calculation mistakes. So the way the quotient rule works is we take first the u, we differentiate it, times v minus u, and now we differentiate the v. And the denominator is just the v function to the power of 2. This is called the quotient rule. It can save you a lot of time, but it can also, because the numerator is a little bit complicated, it can also can cause mistakes if you don't practice a lot with it, or if you maybe forget the formula. This is also because it's a little bit more complicated, like the power rule. But in the end, I would say it saves you time, and what you just need is practice. So let's just calculate an example. So we have function f, which is 5x minus 2 divided by 3x. And then we can already see, okay, we have u, which is 5x minus 2. So the first derivation is 5. And the same way we have the v function, 3x. And then we can see the first derivation is 3. Now we can easily apply the quotient rule. So let's just do it. And okay, first derivation of u is 5 times 3x. 3x is v, minus u is 5x minus 2 times first derivation of v, which is 3 times 3. then the denominator v to the power of 2, so 9x to the power of 2. Then it depends on the taste also. Maybe it does get worse if we now try to simplify everything, but I think in this case we just might have a try. Maybe it will look a little bit better. So it's minus 15x minus 6. And then we see already, okay, it might look actually quite nice when we calculate it a little bit further. Minus 15x minus 6. No, it's plus now, right? And what we have here in the denominator is 9x to the power of 2. 15x minus 15x, so it disappears. Then what stays is 6 divided by 9x to the power of 2. Then we can cancel out and say, okay, we have 2 and 3, so 2 divided by 3 and x to the power of 2. Or we could also write, but this really depends on the taste, you can write 2 divided by 3 and then x to the power of minus 2, right? When you apply a minus, then it always means you can also, like 1 divided by x is x to the power of minus 1. And this you can also apply here. It depends on the taste, how you want to show the result. But I would stop here and say this is the first derivation of f. So all you have to know is the quotient rule. You should know it by heart, because if you don't, you can also do it like you can calculate manually with the, I think it's the product rule you can apply, and the factor rule, and then you will also get the result if you calculate correctly. But the thing is, when you know the quotient rule by heart, then you're a lot faster and it may save you mistakes. So I would just suggest you for exams, for homework, etc., just learn the quotient rule by heart, or you can also do it, maybe just write it down and then calculate 20 exercises, and then I think you will also know it by heart, because it's actually very fast. And then when you know it by heart and you have practice, then it's quite easy and you don't make mistakes in exams. That's the quotient rule. Thanks for watching. Practice makes perfect. Further exercises with solutions you can find on my website, which is www.worksheets.com.